Avinash was asking this question. If we left xy, then whatever comes in next will be the direct object. We don't want that. But there is a way of doing this which does not involve abstracting later, but then it's a slightly more complicated. It's the same thing in effect, and perhaps if you read Montague's original, you'll see what you basically do is you put in a new variable, you abstract over it at the point where it will matter. So it's a way of, you have to fix it. This is an easier way to sort of place the burden on the co-indexation rule. But the end result is that when you hit the binder, it should target the same position, right? So that's a way of getting around that. Okay, everybody good with so far on this? Okay, so yeah, yes.
How does this lambda actually abstract so predicates? I got the idea. How does it get with the arguments that I got? How does this happen with this predicate that I did?
So you tell me, what does by mean? Just the word by. That's what you're asking, right?
Yeah.
So you tell me, what do you think when you think by, as opposed to sleep and as opposed to eat? Like how, these are different words, right? So I'm putting you on the spot, but I just want you to play it out a little bit for yourself.
Buy means there should be a buyer and there should be a thing that the person will buy.
Okay.
And sleep where there should be a person who will do that act.
Okay, so this is the basic, whether it's a two-place predicate or a one-place predicate, right? So, okay. How do we distinguish between eat and sleep? Eat and buy, they're both two-place, right? Eat is also like that. So clearly there's a lexical meaning that people here have done lexical semantics, but basically there's ingestion in eating. That object should be edible, whereas buying, it should be something, there's some transaction involved, ownership changes. So those are part of the lexical meaning, but they're both two-place. Lambda abstraction is a way of capturing that it is two-place or one-place, right? Because this says this is a one-place predicate, right? But it became a one-place predicate after I filled in one argument. But you started when we didn't have it in a sentence, you just had the predicate and you had by. Your question is who, what, right? These are the two questions you have. And that's what the lambda x, lambda y is capturing, that it's looking for two arguments. So those of you who know functions, it says I'm a function from something of type E, x, to a function from something of type E, y, to something of type t, which is truth. Once you give me those two things, then I can say whether it's true or false. I get a truth value. So the lambdas are a way of marking how many things you need to saturate, how many positions before you get to a truth value. Does that make sense? So just the word by itself, it's a basic way of capturing transitive versus intransitive. Mind you, of course, transitive and intransitive is a syntactic thing, right? So eat in English conceptually is always two-place. But I can say he has eaten. That's an intransitive sentence. So there are those issues, but this is capturing the meaning part of it, that you need two arguments. Some would argue that some would say transitive eat and intransitive eat are the same predicate. You start with lambda y, lambda x in both cases. In one case, you have a detransitivization rule where you bind off the internal argument with an existential and you say, then you get a derived predicate that says eat something. So then you say John ate something. There are issues about it's got to be something generic, etc., etc. The other way to is to say that actually there are two verbs. One is a one place, the other is a two place. So I'll leave that for. But is everybody good with this? Yes.
What's the function that cap info?
Cap info. Okay. So that's Montague's intentional operator. If you remove the cap, then this is either true or false. So this is the extensional. In this situation, there exists an X. X is a book. Bill bought X. If there happens to be, let's say, Pride and Prejudice and Bill bought it, then you'll say yes, it's true. If not, you'll say false. But this is talking about the set of worlds in which it is true. So not just this, whether it's true or false in this world, but what it would take for it to be true. So that's simply a way of generalizing across possible situations, possible worlds. So this is sort of the idea behind the possible sentence, denotes the set of worlds in which it is true. Okay.
Now, is there something about lambda extraction also? I think I have complete those.
Lambda abstraction.
No extraction.
No, not extraction. Yes.
I guess it's kind of a silly question.
Mm.
But in the denotation for 1 and 3,
Mm-hmm.
so 1 you say it's functional application, and
Mhm.
3 you have lambda conversion, but it's the same thing that's happening.
Oh, what did I say? Predicate abstraction.
No,
Oh,
no, functional application and lambda conversion.
where did I do lambda conversion? Okay. 1 second. Okay. So
Is that a difference?
let me see why I said okay. So his question is on one, in describing what I'm doing. In one, I'm saying functional application. Apply the meaning of V to the meaning of DP, right? Or apply feed DP as an argument of V. So that's functional application. In the second one, again, I take the VP as the function and I feed DP as its argument. And then in 3, so what I should have said was, you can't do functional application right away, right? You have DP, IP. No, I know. I'm getting there. I have to give myself time to come up with an answer. No, I don't have the answer. So DP, IP, the types don't match. How do I fix it? Well, DP is fine. Lambda P, blah, blah, blah. In the IP part, I've done predicate abstraction, right? I've abstracted over the X sub I and made it into a predicate. And now I have done lambda conversion twice. Basically, what I could have left, this is, now I can do functional application. So your point is correct that after I do predicate abstraction, see, here's one thing I'll tell you guys, okay? Those of you to whom this is sounding a little too much, listen to it however much makes sense and go with the flow. I really think that this course can be understood and you can gain at various levels. If we end up spending too much time on making sure everybody gets all the, crosses their T's and dots their I's, we probably won't get to the interfaces as much, right? We would be doing semantics too. On the other hand, these are legitimate questions, so I try to balance both. So I think this is a good question, but if it is problematic for anyone, don't worry. If it comes in the way of, you were all okay with the first half of the lecture anyway, right? Everybody was. You will be good again. If you're not, I'm not saying you're having a problem with this, but his question is, couldn't I have just said functional application and been done with it? Yes. But I wanted to show the steps that you get to the final product by doing lambda conversion twice. So in the first case, lambda P, you're looking for properties. Once you put in the property, then you get, now you have something that is type T, but inside that there's still one lambda that needs to be resolved. So that's why I added lambda conversion again. It's just an elaboration. In these cases, there was no elaboration needed because function application was straightforward lambda conversion, right? In this case, you create a lambda abstract, then you have to do it. So, but yeah, nothing fundamentally different. Good? Okay. Oh my God. Okay, I'm going to say one thing. And maybe just start this and then we come back after lunch. Is that the idea? Yeah, okay. So here's the thing about questions. How do we know what the meaning of a question is? Do we have any direct intuitions? So for sentences, Bill bought a book. I can create the scenario, I can draw a picture. I'm horrible at drawing, but if I could show you a picture and I could do a truth value judgment task. You could say yes or no, true or false. What do we do with questions? Can I say true or false to question? The heart of Montague semantics is, is in terms of possible world semantics, in terms of truth conditions. It's all based on whether something is true or false. That's what we have intuitions about. Questions have a level of abstraction because, as we were discussing, it's about relationship between questions and answers. We have direct intuitions about answers. Is that true or false? We do not have any direct intuitions about questions. We have intuitions about question-answer paradigms. So this is one step up. Then, as a linguist, you have to decide: is this an answer? Is this a possible answer or not? So we'll do that after the break. For now, here's what I'm going to look at. Given that we have about 10 minutes or so before break. If you look at 13, the structure is very similar to what we had earlier. There are 3 levels, right? There's an IP. I'm on page 4 now. And now I'm doing which book did Bill buy, okay? Structurally, I think they should be very similar. Yeah, I mean, I did a triangle for IP, but the same idea, right? VP, there's a gap inside VP, the internal argument is missing. And I didn't really, oh no, there is a difference. What's the difference? C is in a different, or the fronted argument is in a different position, right, with relation to C. Yes. And that's going to be very crucial because there are 2 things we want to do with questions. One is the same. It's like you have an operator, you have a variable, and this indexing has to play a role in somehow making sure that this belongs here and not here. That part is going to be common. We're going to treat it as an existential quantifier. But we need one more thing. We need to go from a proposition to a set of propositions, right? So a question differs from an interrogative, differs from an declarative on type, right? It's a different type of, instead of being just a proposition, it's got to be a set of propositions, basically. So how do we get that? We can think about the structure in 3 as chopped off in 3 places, okay? So the first part is the TP part, IP, TP, whatever you want to call it. That we call the question nucleus. And whether I'm doing it for a WH question first because it's the closest analog to a QR position. The other part that people, again, I'm presenting one, the theory of questions that seems to me to have the most relevance or the most, gives you the most coverage. There are other ways of doing question semantics. Again, we have to get to move on, so I'm choosing one. But the idea is you have a question nucleus that, just like in the other case, has a free variable, let's say, for WH questions, at least a free variable position. So you can almost see that there's something, missing there. Now the difference is going to be, they will come in between, they'll come a C, which is plus WH. Again, we are used to thinking about, some verbs embed plus WH complement, some verbs don't, right? We say, if I say in English, John wondered that he is leaving, that doesn't sound ungrammatical because wants a plus WH complement. John wondered when he is leaving is fine. John believes where he is going is odd because believe takes minus WH. So this plus minus WH is it's called selection, right? That's where we say C plus WH is the position. It's just marking what is my clause type? Am I an interrogative? Am I a declarative? Am I a question? Am I an assertion, proposition? And then which book, let's say, is in the spec of this CP. That's one way of separating it out. What are the 3 parts? Question nucleus is basically of type T. A sentence, it has all its arguments saturated, one of them with a free variable. C is where the shift to question set of propositions will happen. But again, just to keep things simple, we are going to introduce the means by which it will get lifted to a set of propositions. We won't quite put in all the lambdas right away. So the idea is, instead of it denoting bill bot x sub I, it's going to say P is equal to bill bot sub I. So this P, we'll see how you can use this P later, okay? But that's what's getting introduced there. Later we'll abstract over it and we'll say the set of propositions P such that it is equal to bill bot x sub I. So that's going to be the way in which we will move from proposition to set of propositions. And then we already know how we did sum book. This one is basically sum book, okay? And we'll do exactly what we did with bill bot sum book, we'll do here, except there's this P sitting in the middle which won't bother us too much. And then we'll abstract over P and we'll get exactly what we want, okay? Let me see if there's anything else that I want to... Should I go through this and then break, or should you tell me what? Let me quickly run through it so that it sits in while you're eating. It will take space, and then when we come back we can take... So I won't take questions, I'll run through this. But, okay, so bill bot x sub I, that's the question nucleus, that's exactly what we had for the declarative. 2 is what happens at the level of C0. The meaning of C0 is I'm looking for a proposition such that that proposition Q is equal to P. P is my free variable. So I do lambda, okay, ignore all this intentional. Basically you're doing functional application. You just have to make it into a proposition. So basically what you're doing is functional application. You say, what proposition is my argument? So what is the argument of C? It's this IP. So I make it into a proposition just like I had done earlier. And now I do functional application, and I should have put in this, I should have done the lambda conversion for you. You will get, once you put in this thing in the parentheses, so 2 should get resolved as P equals up of, sorry? Bot bill, yes, exactly. P equals up of bot bill x sub I. Okay? It's type T, right? Either P is equal to this or P is not equal to this. So it's type T. And now, just like in the first case, when we had something of type T and we had something of type ETT, a set of properties, there's a mismatch, right? The functional application as it stands can't go through. So what do? We look at the C part and we say, is there a way for me to make this into a property? Lambda calculus gives you a way. You look and you see, is there a free variable with the same index? So which book has the index I, which I forgot to put here. So that which book should have the index I. And so if I can find an x sub I, I can abstract over it, which is what I have done on 3, right? So lambda P, there exists an X is a book, and P is a property of that book. That I got from which book. So on this view, which book is the same as sum book, except that it must go, so this is where agreement will play a role. It will say, I need a plus WH to license it. That's one way to think about it. Some book will say, I need to be in a minus WH environment, like that's why I'm below C. I don't look at whether C is plus W, I just work with what I got. So this will be a morphological requirement that it will impose. Semantically, it doesn't care. But since morphologically it says I'm only going to go with plus C, plus WHC, the job is done for it. Then the semantics simply says I look at it and I'll abstract over lambda x sub I. So you see what is in the bracket. And then I do lambda conversions. And in the end I get there exists an X is a book, and P equals up of billbot X. X, by this time I've done all the resolutions. And the last step, which is a simplification to do it at the end, we could have If you read Cartoonan, you'll see he defines his C in a way that it's already in there, but don't worry about it. Basically, this says lambda p. So look at all the propositions in the world. It is raining. Bill is smart. Bill bought Emma. Bill bought a bicycle. Any proposition you can think of. I am going through all these propositions and see if it makes the formula in my scope true. What is the formula? It says find me an X that is a book. So that's the first control. You need to find a book. And then you have to see whether this proposition that you have is the same as Bill bought that book. So let's say we have Emma. The proposition we are looking at is it is raining, for example. So what we are going to test is whether there's a book. Of course, I can find the book Emma. And I put it in there, Bill bought Emma. Is the set of worlds in which Bill bought Emma the same as the set of worlds in which it is raining? No. There'll be some worlds in which he bought Emma and it's raining, so they are not related to each other in any way. So they are not the same. So it is raining is not a possible answer to what did Bill buy. Suppose Bill bought a magazine. Then I found that will be ruled out because that X sub I is not a book, so I can't use that. I'm stuck to book. So either Emma or Pride and Prejudice in our world. Maybe he bought both, so I have to look at both. I found a book, Emma. So now this proposition, he bought Emma, is equal to the proposition Bill bought X sub I, where X sub I is Emma. Right? So that will go in there. What about the proposition Bill bought Pride and Prejudice? Yes, I find a book, Pride and Prejudice, such that binding X sub I, giving X sub I that value, makes it equal. The set of worlds in which Bill bought Pride and Prejudice is the same set of worlds in which he bought an X sub I, such that that X sub I is Emma, right? Is bound by Emma or Pride and Prejudice, whichever one I'll say. That's how you get the question to denote exactly those two propositions. Everyone good with the general schema? Okay, let's break. Yeah? Okay.
We'll break for lunch. We'll go to the place together, and we should be back by 2.
Has everyone signed in the link?
So should I have reserve it to stop this? Oh.
I think it's tomorrow. It's okay. It wasn't too hard. Oh, so this is